Hello students, welcome to ACE Engineering Academy and ACE Online. Myself, your Ramesh Masuna sir. And here we are going to start GATE 2026 Score Booster series, where we are going to solve numerical answer type and multiple selection questions. Listen to me carefully, and this session is definitely going to be useful for you. It is not just listening to me. So while I am solving numerical answer type questions and multiple selection questions, I recommend you to respond before my explanation complete with an answers. Right? Chalo. When it comes to the database management systems and data warehouse, we have a syllabus: database design, implementation and maintenance. In the design, we have ER models, relational models, and in the schema refinement, we have functional dependency and normalization. When it comes to the implementation, relational algebra and calculus, structured query language. In the maintenance, we have transaction management, concurrency control, recovery management, file organization and indexing. And even DA people have data warehousing. So this is a syllabus for database management systems and data warehouse. And for DA people, you don't have these two topics: transaction management, concurrency control and recovery management. And CS people, they doesn't have data warehouse. But here in this series, I am going to cover the questions of database management systems and data warehouse. Okay. So without wasting the time, we'll go ahead. And during the live session, you can please respond to the questions. Okay. So I will check your responses in the chat box. Fine. Look at the first question. So I'll also discuss the questions in the order of database design, implementation and maintenance. Fine. Read the question carefully, understand and answer it. Yeah. So, Ankit Singh, hi. Right. So, look at the question, what it is asking. In a hospital, this is a kind of question I am expecting. In a hospital, there are various departments. Each doctor is associated with one department. There are so many departments out there. There are various departments. Each doctor is associated with one department, means one doctor associated with one department. A patient gets registered to a department under one doctor in the department. It may be required that he or she may be treated by other doctors of same or different departments. So doctors are suggesting various lab tests for the patients. Those are noted. What test doctor is suggested to the patient is noted along with their reports. If you want to design a schema for the above system, what are the possible entities? So what is an entity? Entity is a real world object that has some attributes to describe. Now, by looking this scenario, what we understand, it is about hospital. In hospitals, we understood that there are various departments are there. Number of departments are there. It requires to have details about the departments. Is the department is there? Okay. Here report, doctor, patient, test. Department is not given in the options. So we require to have department could be one entity set because multiple departments are there. What is the department? Their details are required. And each doctor is associated with one department. So hospital should have doctors and required to have doctor's details. Doctor is also one entity. Okay, B could be the answer, right? But I am talking about MSQs and NATs. So multiple selection questions, more than one option might be correct. a patient gets registered to a department under one doctor in that department. Okay, means it requires to have details about the patient, because hospitals should have doctors and patients. So patient is also one of the entity set. And various tests, right, doctors suggest various tests. Doctor is suggesting tests to patients. Doctors are suggesting tests to the patient. Which test is suggested to which patient? Which doctor suggested which test to which patient? The test information is required. Means if I am saying doctor is one entity set and suggestion is a relationship, suggest, okay, to patient, patient is another entity set. Now suppose if doctor suggested some test to a patient, it requires to have test information. It requires to have test information. So means test is an information, not required to be an entity. So it is wrong. If a test is conducted for a patient, then test report also to be noted. So test report also be noted. What test is suggested? What is the report of the test? So means test and report are the informations, or we can call attributes, but not necessarily be the entity sets. So that report and test are the attributes, but not the entity sets. Doctor and patients are the entity sets. This kind of analysis is possible. So this kind of questions are possible to be asked before this GATE examination, right? Before this GATE examination 2026, this kind of questions are not asked, but expected to be asked. Okay, based on your analysis, how you can come up with some conclusion, which things are to be entity sets, which things are to be relationships, which things are to be attributes. These kind of questions are possible to be asked. Okay, so answer for this question is B and C. Anyone answered? Wow. Srivastav, Madanshu, Jeevan, nice. Tejasvi, Tejashwar Reddy, nice. You people are answered. Chalo. Next, we'll go ahead with ER2 relational model translation. Look at that question and try to understand and answer the question at the earliest. Numerical answer type question. So Anand is asking, like, do you need to register? Just inquire with the ACE helpline so that you will get to know that revision series, is it required to be registered by you or not? Okay, fine. Here I am getting quick responses. Santosh 4, Madanshu 3, 4, 3, 3, 3, 4. Okay, so why you people are giving multiple answers? Okay. Okay, Santosh, Madanshu, Saroj, different answers I am getting. Okay, fine. So what will be the answer for this? Okay, let me explain you. This is an aggregation. What is an aggregation? It is a relationship, participate with relationship. It is an aggregation. Aggregation is represented with dotted box. Now question is, if we convert the above ER model into relational model, the minimum number of tables is R. We know that every entity set one table. Here how many entity sets? 3 entity sets. So 3 compulsory. 3 compulsory. Next we have to decide whether relationship should be represented as separate table or not. We have to decide. Here relationship should be represented as separate table if there is no key constraint from any of the entity sets. Here monitors does not have any key constraints. Arrows are not there for monitors. So this should be represented as separate table. Look for sponsors. Do we represent sponsors as a separate table? No. Why? Because projects are the key constraint to the sponsors. When projects is a key to the sponsors, now you can merge sponsors with the projects. These two together one table. So how many tables? Employee, monitors, department and project and sponsors, one table. Totally 4 tables is the answer for the question. So totally 4 tables. So 4 is the correct answer for the question. Some of the students have given 4. Okay, nice. Santosh, Sharon, and those who have done a mistake, please check it out where you have done a mistake. Nikita, Darling Diksha, oh, Rashmita Muthyala, nice. Tejashwar Reddy, Jeevan, and some of you are given 2 also. Why 2? Why 2? Please check it out where you have done a mistake. Okay, where you have done a mistake. It's simple. What you have to do, every entity, one table, relationship, you have to decide whether to have a table or not. If no key constraint, separate table. If key constraint is there, if no key constraint is there, separate table. If key constraint is there, match it. That's it. Okay. So first question on ER models based on analysis. Second question on translation of ER model to relational models. Then third question. It is based on the relational model foreign key constraints. Have a look at this question and answer it quickly. Just I'll wait for 30 seconds. Okay. Praveen, why not 175? Do you want 175? Okay. Very good, Mutyala. Nice. So, but answer is numerical, right? So, it is asked, what is asked? The set of all tuples that must be additionally deleted to preserve the referential integrity when the tuple 2, 4 is deleted. Okay, we have solved this kind of question. Fine. Santosh, what happened to you? Sharon? That is wrong answer, yeah. Fine, fine. Apurva Joshi, right? Madanshu, check it out what you are done a mistake. What is given? The following table has 2 attributes A and C, where A is the primary key and C is the foreign key referring A. C is a foreign key referring A. With what condition? On delete cascade. What is the meaning of on delete cascade? Whenever a tuple is deleted from the parent, all the related tuple from its child also be deleted. So here the same table has primary key and foreign key. With respect to primary key we call parent, with respect to foreign key we call child. So when we have parent child relationship, what is question asked? The set of tuples that must be additionally deleted to preserve the referential integrity. What is the meaning of referential integrity? We call foreign key constraint. When the tuple 2, 4 is deleted. When you delete 2, 4, you are deleting 2 from the parent, because 2 under A column, A is a primary key. With respect to A, we call it is a parent table. Whenever a tuple is deleted from the parent, we have to check the related tuples in the child. Now 2 is there in 5, 2 and 7, 2. These 2 are treated as child tuples. 5, 2 and 7, 2 are called child tuples. So whenever you delete 5, 2, because on delete cascade is there, we have to delete 5, 2 and 7, 2. Whenever you delete 5, we have to check its related records. When 5 deleted, its related record is 9, 5. So it has child record 9, 5. Because on delete cascade, delete that also. But whenever 7 deleted, 7 is not in the child. When 9, 5 deleted, 9 is not in the child. Additionally, how many records are deleted? 1, 2 and 3. So answer for this question is 3. So this question might be in the other way also. Instead of asking how many additional records to be deleted, what will be the number of records after the deletion is completed? After the deletion is completed, what will be the number of records? These 4 are deleted. Number of records are 1, 2 and 3. Those are the number of records after the deletion completed. So it might ask a question, if 2, 4 is deleted. Are you getting my point? If 2, 4 is deleted from the above table, they didn't mention anything. So all these specifications are given, that they don't mention anything. But if you see, if 2, 4 is deleted, what will be the resulted number of tuples? Then what is the mindset of the students? If 2, 4 is deleted, remaining are counted. But what actually happens when 2, 4 is deleted? It causes 5, 2 to be deleted, 7, 2 to be deleted. When 5, 2 deleted, 9, 5 also be deleted. These things you have to check it. Okay. Concept is same. the way of asking questions might be different. So focus on how they can ask you questions. Next, we'll see questions on functional dependencies and normalization. So this is based on equivalences. Consider the following two FD sets on a relation R of ABC. Two FD sets are given, F1 and F2, and ask you to find F1 covers F2, F2 covers F1, F1 not covers F2, F2 not covers F1. This is a MSQ type of question, right? So almost everyone given the right answer for the previous question. Muhammad Farooq, nice explanation. Wow, Sai Puneet Reddy, nice, nice. So instead of just giving the answer, these people have selected, given the explanation also. Nice, definitely appreciable. In dependency preserving, can I use this test? What test? That is not required, my dear Ankit. Okay. So it is MSQ, right? The fourth question, multiple selection question, MSQ. I have added this question in the session because so far no question given on equivalence of two sets of functional dependencies. On equality, no question is given. So it is a most expected topic, and that too MSQ type of question. Okay, it is expected type of question. It is expected type. So what is the question? We have two dependency sets are given. The question is F1 covers F2 or F2 covers F1, F1 not covers F2, F2 not covers F1. So how can you say F1 covers F2? What is the meaning of F1 covers F2? Every dependency of F2, if we can determine using F1, we can say F1 is covering all the dependencies of F2. Check for F1 is covering F2 or not. Can AB derives C possible with F1? What we have to do? AB closure we have to do in the F1. When you take AB closure, AB with B, C possible, right? Now, when AB to C, we have to check of F2 with F1. What we do? AB closure we have to do, that is ABC possible. Similarly, AC to B, what we have to do? We have to check for AC closure, AC with AB possible, AC to B possible. B to C directly there. So I need not write. So F1 is covering F2, means every dependence of F2 you can get using F1. F1 is covering F2. Check for F2 is covering F1 or not. So F2 covers F1. What does it mean F2 covers F1? Every dependency of F1 you determine using F2. Every dependency of F1 determine using F2. What is the F1 dependency? A derives B. You just take the closure of A. What is the closure of A in F2? What is the closure of A in F2? A closure is A only, but not B. So means F2 is not covering the dependencies of F1. F2 not covers F1. So what are the correct answers? A and D. So how many of you gave? Oh, nice. So many. So many. I think I need not to take any names. Fine. Then go ahead with the next question. This is on minimal sets of dependencies. On minimal sets of dependencies, so far asked only one question in 2017. After that and before that no question was there. It is also one of the most expected topic on minimal covers, but not in the conventional way. Question could be slightly different like this. Consider the following FD set on a relation R of A, B, C, D, E. Okay, the dependencies are given. Choose the correct option. These are the options given. Check for this quick. Happy birthday. Whose happy birthday? Okay. AB, AB. So what is asked? Consider the following FD set on a relation R of A, B, C, D, E, and these are the dependencies given. Choose the correct option. What is given? AB to D is redundant, BC to E is redundant, D to E is redundant, AB to C is redundant. So how do you find a particular dependency is redundant? If I am saying AB to D is redundant, this is redundant. If AB to is redundant, this should determine from other 4 dependencies, like assuming this is a dependency 1, it is 2, I am calling it is 3, and this is 4, and this is 5. If AB to D is redundant, then AB to D we have to get with 1, 2, 4, 5. What is AB closure in 1, 2, 4, 5? AB, with 1 we have C, with 2 BC we have D, so that with D we have E, with AB we are going to get D. So means 3, dependency 3 we can get with 1, 2, 4, 5, then I can say AB to D is redundant. Perfect, this is the correct answer. Check in this way, don't find minimal set, yaar. What is asked, you just do that only. Okay. BC to E is redundant. Check for BC closure. What is a BC to E? 5th one you are checking. 5th one you have to check with 1, 2, 3, 4. What is BC closure? BC, with 2 we have a D, with 4 we have a E, right? With 4 we have a E. What is expecting? BC should derive E. So BC to E is also redundant. D to E is redundant, means 4th one we are checking. How to verify 4th one is redundant or not? 4th one you should get with 1, 2, 3 and 5. What is D closure in 1, 2, 3 and 5? D closure is D but not E, so that D to E is not redundant. Check for AB to C, first one. What you have to do? AB closure we have to check with 2, 3, 4, 5. What is AB closure? A, B, with 3rd one we have a D, with 4th one we have a E, but are you getting C? No. So means it is also not redundant. Which dependencies are redundant? Option A and option B are the redundant dependencies. Okay, good. Almost everyone given the right answer. Shraddha Deshmukh, you selected only A. Mutyala Rashmita, you also selected only A. So check. Hello everyone. It is not that you have to select the right answer. You should also select why particular option is wrong. This way you have to prepare it. So it is not that A and B is correct. You should also know that why C and D are incorrect. That way you have to prepare. Okay. Then next question on keys. Go ahead with this question. Can you make it a bit quicker? Okay. R of A, B, C, D, E with 3 candidate keys A, B, B, C, C, D, 3 candidate keys. So far question asked on 1 candidate key, but not even 2 also, but expected if 3 candidate keys are given, how many super keys are possible. So I hope you are understanding what kind of questions I am giving you. All are expected type. Okay. Means not in the same conventional mode. Different question, which was not asked in the previous year. R of A, B, C, D, E with 3 candidate keys A, B, B, C, C, D, then the number of super keys are. How many super keys? Oof, that's quick. Praveen, sir, మీరు habits లో ఉన్నారా? Yeah, I'm in habits. What, Praveen? Okay, good. It is 16. So how do you calculate the candidate keys? Sorry, how do you calculate super keys? Because 3 candidate keys are there, A, B, B, C, C, D. If I am treating A, B as a candidate key, other attributes are C, D, E. are the other attributes. With them we have to find super case. If BC is a candidate key, combinations we have to find BC with along with other attributes. What are the other attributes? A, D, E. When CD is a candidate key, along with CD we have to check with other attributes combinations. What are the other attribute combinations? A, B, E. So we have 3 sets now, X, Y, Z. When 3 sets are given, we have to find the possibilities number of super case. With CDE we have a 2 power 3 super case are possible along with AB. And with ADE 2 power 3 combinations. With ABE 2 power 3 combinations in that. With something which is common between X and Y has to be counted for 2 times, is counted for 2 times, has to be eliminated for 1 time. So minus. What is common? DE common. Means with DE how many possibilities occurred? 2 power 2. With X and Z how many combinations are correct? So E is only 1 common. With that we have 2 combinations are possible. With this Y and Z, which is common, AE means 2 attributes are common. So 2 power 2 has to be eliminated. So means that elimination happens with respect to XY, XZ, YZ. So means double time it is done. So 1 time it is to be added. So what is common of all the 3? All the 3 common is E. Whatever is there with E, it is removed for 2 times. So add it back 1 time. So with E 2 power 1. So 2 power 3, 2 power 3, 2 power 3, 8 plus 8 plus 8. How much? 8, 8, 8, 24. Minus 4, minus 2, minus 4, minus 4, minus 4, minus 8, minus 2, minus 10 plus 2. So how much? 24 minus 10 plus 2, 24 minus 10, 14 plus 2, 16. So the number of super keys are 16. So almost everyone given the right answer. Okay, that's quick. Almost. Ankit Singh, how you have chosen CD, ABE? So Ankit, when AB is a candidate key, to find the super keys, we have to check the combinations with CDE, right? Other attributes. When AB is a candidate key, we have to check combinations with CDE. So means with the C, with the D, with E, with CD, with the CE, with the D, and with CDE. These are all the possibilities, right? Or with nothing. So how many possibilities are there? 8, like this. So when AB is a candidate key, along with other attributes, combinations are super keys. Okay, Ankit Singh, done? Praveen, okay, meer akkade unnara? Done, good. Next, question number 7. Consider relation R of A, B, C, D, E and set of all FDs. And which of the following statements is R true? Find it. Which of the following statements are true? Darling Driksha. Sir, are these questions are expected or most frequently asked questions? So it is the same concept, what Driksha, same concept on which questions were asked, but I am giving you in a different way of asking, because definitely I am expecting this time question paper should be bit tougher, definitely. So focus on it. Means you should have, like, I am not teaching any new concept, but I am giving you new question, new questioning, that is important. Look at consider relation R of A, B, C, D, E, F and set of all FDs and R as given below. Okay, given which of the following statements is R true? Every attribute is a prime attribute. Okay, question is about prime attributes. 5 candidate keys are possible. Attribute B is part of each candidate key. Attribute C is part of 2 candidate keys. See, just asking in a different way. What is a candidate key? Can I say AB is a candidate key? Just check for the closure of AB. AB closure is A, B, C, D, E, F, all attributes. Perfect. AB is a key. When AB is a key, A and B are called prime attributes. When prime attribute A appear in the right hand side, then what we can do? Replace with the left hand side, F. Now F is also prime attribute. Now F you replace with E, so EB is also candidate key. Now E is a prime attribute, replace with D, DB is also candidate key. When D is a prime attribute, replace with C, CB is also prime candidate key. When C is a prime attribute, replace with AB, so you are going to get ABB, so AB, same. So how many candidate keys? 5 candidate keys. So B is correct. Have you done? Oh, ABC. Perfect. Very good, Prasanna Kumar, Ajay Gandham. Very good, very good. Nice. Nice, nice. Quick. Oh, very good. So I'm getting quicker responses. So 5 candidate keys. Every attribute is a prime attributes. What are the prime attributes? A, B, C, D, E, F, all are prime attributes. What is the prime attributes? Attributes of a candidate key called prime attribute. Okay, perfect. This is also correct. B is also correct. Attribute B is part of each candidate key. Wow. B is there in every candidate key. Excellent. Attribute C is part of 2 candidate keys, but at C is part of only 1 candidate key, not 2 candidate keys. So D is wrong. Got it? Nice. But I'm happy. But most of the students are given the perfect answers. That's a quick. Chalo, go ahead with the 8th question on the candidate case. Muhammad Farooq, how people are doing this much fast? Because they are my students. Muhammad Farooq, ads vastunnaya. Okay, is ads coming? Prakash, ads vastunnaya madhya madhyalo. No? Right. Okay, fine. Darling Driksha, sir, will the revision series starting? Okay, and John will cover all subjects. Yes, Driksha. It is going to cover all subjects. I'm going to announce it when it is going to be started, revision series, and how to register for this. I'll tell you. Okay. Chalo, any answers for this? So far you have done quickly, na? Do this also very quickly. Oh, we are at the 8th question only. Actually, today for this session I have collected 25 different type of questions, but how fast you can do the 25, it is up to you. So which of the following statements is correct about supercase? For a relation R of A1 to AN with each attribute as a candidate key, then the maximum number of superkeys are 2 power n minus 1. Okay, just check for the validity of this statement. Suppose R is ABC, assuming every attribute is a candidate key, means 3 candidate keys A, B, C. If 3 candidate keys, how many super keys are possible? Every candidate key is a super key A, B, C, and the combinations also super key. So AB, AC, BC, and ABC. How many super keys? 1, 2, 3, 4, 5, 6, 7. So there are 7 super keys. This 7 is equals to the power of 3 minus 1. Right now, 2 to the power of 3 minus 1. Okay, this is perfect statement. If every attribute is a candidate key, this is a perfect statement. Suppose you have a clarity, you can directly answer it. If you don't have a clarity, this way you can check it. Okay, fine. Oh, that's quick. Pratham. Wow. Tejasvi Reddy. Check once again. Okay, next, second one. For a relation R of A1 to AN with one candidate key AI, one candidate key is only one attribute. The number of super keys are 2 to the power of remaining attributes. If one attribute is a candidate key, remaining attributes are n minus 1. This is also perfect. B is also correct. I have seen most of the questions, most of the students are solving tougher questions, but they are not solving easy questions. Means simple theoretical questions are not able to solve. Means maybe it is because of theory, but there might be neglecting theory, but should not be neglected. For a relation R of A1 to AN with a candidate key A1, A to A3, candidate key is 3 attributes now. The number of possible super keys, if 3 attributes are there, number of super keys are remaining attributes 2 to the power of n minus 3. It is also perfect statement. For a relation R of A1 to AN with a candidate keys AI and AJ, two candidate keys, and the number of possible super keys are if AI and AJ. So how do you calculate super keys? If A is a candidate key, one attribute is a candidate key, remaining attributes are 2 to the power of n minus 1, plus if AJ is one candidate key, with that remaining attributes are n minus 1 attributes. So how many possibilities are there? 2 power n minus 1. Minus, what is common you have to remove now. What is common we have to remove it, but this common thing is not mentioned. What is common we have to give. So means that common thing should be to the power of n minus 2, because A and AJ except that remaining all are common, right? So to the power of n minus 2, but this is missing, so option D is wrong. Option D is wrong. Okay, so what is the correct answer for this? A, B, C. Oh, good. Tejas, we ready? Done. Good, good. Next question, question number 9. It is on lossy lossless decompositions, dependency preservations. Could you please do it bit faster, because it is 7:40. Relation R of A, B, C, D with FD set. Okay, this is FD set. F A to B, C to D, D to E, and the decomposition is R1 of A, B, C, D, R2 of D. So far questions are asked on lossy lossless decomposition, right? But as a combination I am giving you this time as a MSQ. R1 A, B, C, D, R2 D decomposition. Now question is lossy lossless DP not DP. R1 A, B, C, D and R2 D. R1 A, B, C, D, A to B, C in R1 you can add up because all three are there in R1. C to D, you can write it as C to D and C to E just for easy clarity. C to D you can add in R1, but C to E, C here, E here. So this is to be verified. This is already there. D to E, this one, third one, you can add up in R2, right? What is not covered? C to E is not covered. This one we have to check. Before that, we have to check for lossy lossless. What is required? There should be at least one attribute common. One attribute common. What is a common attribute? D. What is the closure of D? DE. It is covering all the attributes of R2. Therefore, the decomposition is lossless. So first thing, lossless. So lossy wrong. Second thing, DP not DP. So what is the answers? Muhammad Farooq. Oh, very good. That's quick, yaar. AC. What is C? Dependency preserving. Some people are given AD also. Satish Kumar. Katta. Something. Okay. Is it dependency preserving or not? We have C to E is not preserved. Okay. Just check, is it preserving indirectly or not? For checking, we have dependency with respect to A and C. Check for B. What is a B closure? B only. And when you find for D closure, D only. So nothing more possible. And here D already there. E closure, E only. Nothing more there. Here F1, I can say F2. Now what is not covered? C to E. That one we can cover using F1 union F2. What is C closure in F1, F2? C, D, E, because C, D and with D, E, C to E possible. When C to E is possible, we can say dependencies are preserving. So answer is option C, D is wrong. So maybe some of you people have missed this. Those have not done. Okay? Right? What, Praveen? Don't make jokes here. So just go ahead with this question. Consider the following relations R of A, B, C. It is one question on relational algebra. QABD, RBE and the given instance. What is the number of tuples in the result of the relational algebra expression given below? How many tuples in the result of relational algebra expression given below? So, could you please check it? Consider the following relations P of ABC, Q of ABD, R of BE. 3 tables are given. What is the number of tuples in the result of relational algebra expression given below? What is the number of tuples? What it is doing? Cross product of P and Q. Okay, these two, P and Q, cross product. Here 4 tuples, 4 into 4, 16 combinations. And how to tackle this kind of questions? Join condition is B equal to B and one more condition is D greater than 1. First, which is easy, D greater than 1. D greater than 1 is true for this one you eliminate it. And next, for these 3, whichever it is satisfying, QB should match with PB. Now 3 had a match with these 2, okay, and 4 had a match with this, and again 3 had a match with these 2. So, how many mappings are there? 1, 2, 3, 4, 5 mappings are there, okay. These 2 tuples have double mapping and this 4 is having single mapping, right. PB matching with QB, okay, fine. These 5 mappings, okay. In these 5 mappings, what are the ABD? Okay, these 5 mappings are there, P cross Q, and it is projecting what? A is projecting. What are the A's in this? What are the A's? Here 1 and 2, whatever it may be the 5 mappings, but algebra eliminate the duplicates. So, 1 and 2 you can expect, right? 1 and 2 you can expect. Next is P cross R, first one and the last one. Again 4 into 4, 16 combinations to be verified for RE equal to 12, this one, and this 9 RB should match with PB. That 9 is matching with PB. In the PB, 9 is there, hello. RB is equal to PB, PB equal to RB. So, RE equal to 12, this is only matching, and for that, what is RB? 9. This 9 should match with PB. Do you have a 9 in PB? 3, 3, 4, 5. Oh, no matches. So, means this is also not going to be selected. So, when it is not selecting, so what it is going to select? A, nothing, empty set. 1, 2 minus pi. Actually, what is a minus? It should be there in the first but not in the second. So, which is there in the first but not in second? Both 1 and 2 is there in the first but not in the second. So, how many tuples to be resulted? 2 tuples. Oh, 1, 1, 1. Why 1? Anything wrong from my side? No, it is 2, right? Pratham, 2. So, some people have given 1, 1, 1. Tejasri Reddy, Sai Puneet, Nikitha, Sharon. Why 1? Sir, one more 1, 2 there. One more 1, 2. What is that? One more 1, 2. A and B selected, right? Whatever it may be, 1 more 1, 2 or 1 more anything. But algebra eliminates the duplicates, right? Because even when I selected A from this side or A from this side, here 1, 1, 2, here 2, 1, 2, but whatever it may be, 1 and 2, only without duplicates, only 2 there. So, nothing more than that, okay? Is okay? Rashmita Mutyala, 4, 12 in R. 4, oh, sorry, I haven't checked it, sorry. Here also 12, nice, nice Mutyala, 4, 12, here also 4, okay, nice. Here 4 is matching with, see, This is what expected. You should be cautious. If you are not cautious, see, a simple overlook with the overconfidence, I haven't checked this, so answer is gone, right? Here 4, 2, 4, 12 is there, here also 2, RE equal to 12. So what is a RB? 4, that 4 is matching with this 4, and what you can expect? 2, it is not empty set, it is 2. Now 1, 2 minus 2 will give you 1. So how many tuples are there? Excellent, Rashmita, 1. Nice, okay. Nice, nice, nice. Done. Good one, good one, good one, good observation. This kind of care should be taken, okay? Okay, look at this question. Look at this question. Consider two relations A of PQ, APQ and BPR, BPR as following. Suppose AB and the table is PQR, AB and the table is PQR, okay? AB and the table is PQR. 1 minute. AB and PQR is the output of natural full outer join of A and B. Natural full outer join of A and B. Which of the following statements is our, oh, some data is missing in this, it seems. Okay, fine. Sorry, that some data is missing. Here you look at the question number 16 on SQL. You can expect a good number of questions on SQL, not good number, definitely good questions you can see. At least one question you can see from SQL. From the below table, gift ID, gift name, price, discount, availability is given. So what is asked? Select max of G1 price from gift G1 where 2 equaled max of G1 price, max of G1 price from gift G1 where 2 equaled. What is the inner queries finding? Select count of distinct price from gift G2 where G1 price less than G2 price. Wow. Here one outer query, one inner query. Outer query is gift G1, inner query is gift G2, and outer reference G1 is used in the inner query. Whenever the outer reference used in the inner query, such query is called correlated subquery. If it is a correlated subquery, for each row of outer query, inner query has to be verified. And means for each row of gift 1, inner query is going to be verified. Okay. What it is finding in the inner query? Select count of distinct prices with a condition that from gift G2 where G1 price less than G2 price, where G1 price less than G2 price. So means for the gift 1 in the outer query, what inner query is checking? That price, if it is less than G2 price, that row is selecting in the G2 and it is finding the count. If that count is equal to 2, that gift is selecting, and in that gifts, what is the maximum price is selecting? Okay, we'll check in this way. First gift, okay, check for the first gift. This one, I'm assuming this one is a G1, okay. Now, what is the price of G1? The price of G1 is 500. That 500 is less than G2 price. So 500 less than any of these prices? No. 500 less than remaining prices you will get. 35, 50, 2000, 1500, 3000, 1300. That 500 is less than, okay, 500 is less than G2 price. This 500 is less than all 4 prices, sorry, all 5 prices, 1, 2, 3, 4, 5. So what count you can expect? What count? Distinct prices. Any distinct prices? 3500, 2000s, 1500, 3000s, 1300. All prices are different. So what count you can expect? 5, but it should be selecting with equal to 2. So this gift is not going to come in the output. If I am assuming this as a gift 1, so remaining are gift 2. Remaining are gift 2. What is the price of this? What is the price of this? 3550. It is less than G1 price, less than G2 price. Less than condition false for this, false, 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 false. So what will be the count? 0. Because count is 0, this gift is also not going to be selected. So third tuple is gift 1. What is the price? 2000. Now condition is G1 price, this is a G1 price, less than G2 price. 2000 is less than 500, false. 2000 less than 3550, right? It is false. 2000 is less than 3000, right? Correct, no? This is also right. 2000 is less than 3550, less than 3000, but 1300, false. So means it is a count of 2, right? Now how many prices are selected? 2 prices. 2000 is less than 2 more gifts, right? 2000 is less than 2 more gifts. So what count it will give you? 2. What count it will give you? 2. Means this gift is going to be selected. Little astronaut is going to be selected. Fine, that is selected. Next, assuming this is a gift 1. Now 1500 is less than, false. It is a true. It is a true. It is also true. 3. Count is going to be 3, but equal to false. So that paintings are not going to be selected. Gastronomy, next is G1, remaining gifts you look at. What is the price? 3000, less than 500, false, less than 3550, right? 2000 false, 1500 false, 1300 false. Count is 1. So equal to false. Magic set is a gift 1, remaining gifts you look at. 1300 less than 500, wrong, true, 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 4. Now count is going to be 4, but checking with equal to 2. This gift is also not selecting. Which gift is selecting? Little astronaut is going to be selected. Only one gift is selected. For the selected gift, it is finding the max price, because only one selected, that will be the max price. What is the max price? 2000. So what is the output of this query? 2000. Anybody answered 2000? Wow, nice. Nice, nice. Perfect. So means you need not to check all these things, because you understand that if gift price is less than how many gift prices, and that number of gift prices are less than the given gift price is 2, that is selected. Only 2000 is only 2000 is less than 2 other gift prices. So it is a meaning the third highest gift, we can say. Third highest gift. If you can understand third, what is the third highest gift? 2000. Then answer will be 2000. Finish. So that is a smart work, you can do it. Okay, it is the 17th question. Consider the following schedule, the number of conflicting pairs of operations. Number of conflicting pairs of operations in the schedule as is. How many conflicting pairs? What are the conflict operations? Hello? What are the conflict operations? Read, write, write, read, write, write. On the same data but different transactions. Read 1x, do you have any conflicts? Write 2x. Read 1x and write 2x. This is one conflict. Write 1x had a conflict with read 2x and also had a conflict with write 2x. Right? These two. But read 2x does not have any conflicts. Write 2x, no conflicts. Read 1y, read 2y. Read is not a conflict. So how many conflicting pairs? Hello? This way question not asked but expected to be asked. Right? Perfect. Is it done? Okay. Can you give answer for this? Okay, just check this. Consider the B plus tree given below. Consider the B plus tree given below. This is a B plus tree given. The number of leaf nodes after deleting node 3, 13 and 11 in order is. Because it's a question is about B plus tree, I always suggested you to check for the property. Means whether left is less than or equal or right is greater than or equal. When you look any node above the leaf, you can see it is a 1, left is 1, means left is less than or equal. Once right is 3, 4, means the right is greater than. Your insertion also should satisfy this property after the insertion is completed. Now where to insert 3 first? Okay, this is a deletion. After deletion also that property to be satisfied. If you have to delete 3 and before you delete 3 or 4 or something else, like you just check for the order. What is the order? Here leaf node we have a 3 keys, right? We have a 3 keys. There are 3 keys in the leaf node. That is a maximum 3 possible. So minimum it requires 2. Minimum it requires 2. Based on minimum order, you have to check. If it is falling below the minimum order, then you have to balance it. So based on the balancing, you have to solve the question. Okay, you have to solve the question. And when it comes to the data warehouse, in data warehouse, you can expect a questions on data normalization. And it might be a question on data normalizations. Previously, questions were asked like what is the normalized values of some data. What is a z-score normalized value? Z-score normalized value is the value minus mean by standard deviation. So what is the value? 73,600, but it is a min-max normalization. It is not z-score normalization. It is about min-max normalization. In a min-max normalization, what is the value? 73,600 minus mean value is 12,000 by max minus min, that is max value is 98,000 minus min value is 12,000. You can solve, you will get the answer. And a different type of question that can be asked is a data point in a data set with a mean of 40, and a standard deviation of 7 has a z-score value of -2. How do you find the value data point? The data point is assuming v minus mean 40 by standard deviation 7. So how do you get value minus 40 equal to minus 14? Then value should be minus 14 plus 40. 40 minus 14, 26. So what is the value? 26. You can get in this way, right? Just 1 minute. In the context of data cubes, which operations are used to navigate between the different levels of granularity, to go up a higher level of data and to go lower level of data? So to go higher level and lower level of data in data warehouse, we have OLAP cube operations called drill down and roll up, and slice and dice are just OLAP operations, but it is not for seeing the data at different levels of data granularity. And one question asked in GATE 2025, that is on cube operation, group by cube. Now expecting group by roll up. So what is given? There is a sales fact table, city, product, month and amount, where city has 3 values, product has 2 values and month has 2 values. Find the number of tuples in the output of the following query. The query is from the fact table. What it is doing? It is performing a roll up operation. City had how many values? 3, product has 2 and month has 2. So with this aggregation, what we can expect? 3 into 2 into 2 combinations you can expect. Means for every combination there should be aggregation is found. That is 3 into 2, 6 into 2, 12. When you perform a roll up is decrease in the dimension. So check month is dropped, means month is dropped. We have to check the combinations with respect to city and product only. With city 3, product 2, so how many combinations are possible? 6. Again roll up, drop the dimension. Now you can check with combinations only with city, that is 3. And when you drop this also, it is a grand total. Grand total is 1. So how much grand total? Grand total means irrespective of all everything, grand total. So 12 rows with respect to city, product, month, and 6 rows with respect to city and product, and 3 rows with respect to only city, and 1 row with respect to grand total. So 12 plus 6, 18, plus 3, 21, plus 1, 22. So question is for roll up operation. In roll up operation, the question is number of tuples in the output of the following queries, 22. So because previously it is asked question on cube, group by cube, now this time you can expect question on at least roll up operation. Okay, these are some of the NAT and MSQ questions, and what extent I can give the best I have given in this 1 hour of session. Hope this session is useful, and do remember, answering the question is not sufficient. Do remember, answering the question is not sufficient. You should understand why particular option is wrong. If you know why particular option is wrong, why particular option is correct, this way you prepare it so that your preparation will be perfect. Wishing you all the best. And before that, I have to give two announcements. ACE is conducting a pre-gate test 2026 on 18th January 2026. You can register for pre-gate exam by scanning the code, and it will be as like real-time exam. So it means on par with GATE 2026 exam. So definitely it will be helpful for you. I suggest every one of you please register for pre-gate exam, which is going to be conducted on January 2026. And one more thing is, we are going to start the revision session from 10th January 2026, GATE 2026 revision series. And this revision series will be for half day of the class, like some 7 to 1, some 8:30 to 1 classes, means half day, where we are revising the entire subject with beautiful examples, practice questions, so that that revision strategy, revision will be helpful for you, and don't miss any revision session and not even a single minute of lecture. If you want to register for a revision series, just scan the QR code. Just finally, I would like to say only one thing. So most of the students are saying, sir, time is approaching, time is getting right early, right? Because where less time is there, huge things are to be discussed. Don't worry about less time or huge time. So forget about your rank and all. So only one thing I can say, जीत और हार तो परिणाम है, कोशिश करना हमारा काम है, कोशिश करते ही रहिए. Give your best, do your best, don't stop giving your best, right? ऐसा मत सोचिए हमारा टाइम कम है, मैं चलो मुझसे नहीं हो पाएगा, मैं ड्रॉप करूंगा, ऐसा नहीं है, right? What extent the best you can give it, okay? Do your best. So I can end the session with a big thank you for all of you, and thank you all of you for your support and listening to me this session, and wishing you good luck, all the best. See you on revision series. Thank you.